lesson for today. This is the second lesson in Unit 3 of Integrated Math 1. As always, we'll start with our warm-up for today. So take a second and see if you can do that. Okay, so number 1 here, we're just simplifying this numerical expression here, negative 2 plus 6. If we start from the inside and kind of work our way out, there's multiple ways to do this. But if we start from the inside and work our way out, we're going to have negative 2 plus 6 is 4. 4 times 3 is 12. And then you're at 12 minus 7 equals 5. So these are all equivalent and they're equal to 5. Number 2, if we have 6 times a fraction of 7/6, and this is going to come up later when we talk about graphing linear functions especially, but this is really 6 over 1 if you want to think about it that way. But as we've talked about before, you can either multiply 6 times 7 first and then divide by 6, or divide 6 by 6 and then multiply by 7. Well, 6 divided by 6 is just 1, and of course 1 times 7 is just 7. So these 6's reduce to 1 and simplify quite nicely there. Number 3, as we've talked about before, negative exponents are really just a reciprocal. And so in this case, we have 8 to the negative first power is going to be 1 over 8. Number 4, which is arithmetic? So which of these two sequences is arithmetic? It might look a little weird because we're dealing with some fractions here. In the first one, we have 1/4 and then 1. So maybe we're multiplying by 4 there. But then the next one's not, right? And it's not multiplied by 4. So maybe that's not geometric. So maybe let's check and see if this is arithmetic. So 1/4 plus 3/4, it would be 4/4. So 4/4, and 4/4 is 1, right? 4/4 plus another 3/4 will be 7/4. And then 7/4 plus another 3/4 will be 10/4. Plus another 3/4 will be 13/4. Plus another 3/4 will be 16/4 or 4. So this is 16/4, which is just simplified or reduced to being 4. All right, so this one is arithmetic. Let's check the next one just to see here. Let's see, 7 and then 7/2, and then 7/4. Let's see. 7/2 would be 7 times a half. And then 7/4 would be 7/2 times another half. You see how the denominator is being multiplied by 2? If the denominator is being multiplied by 2, that means you're dividing by 2, or you're multiplying by a half. Since we're multiplying by a half, this one is geometric with a common ratio of 1/2. All right, number 5, which of these is prime? We haven't really talked about prime numbers yet this year in our video series, so I figured we could bring that up now. So which of these is prime? So let's think about the definition of a prime number. A prime number is any number is only divisible by two numbers, two different numbers, 1 and itself. So let's keep that in mind. So let's start with 8. Is 8 divisible by two different numbers, 1 and itself? No, because that's also divisible by 2 and 4. Is 7 divisible by 7 and 1? And that's it. Yes. So 7 is prime. Is 6 only divisible by two different numbers, 1 in itself? No, because it's divisible by 2 and 3. Is 5 divisible by two different numbers, 1 in itself? Yes, just 1 and 5. Is 4 divisible by two different numbers, 1 in itself? No, because it's also divisible by 2. Is 3 divisible by two different numbers, 1 in itself? Yes, just 3 and 1. Is 2 divisible by two different numbers, 1 and itself? Yes. So 2 is the only even number that is also prime. So good trivia question there. Number 1. This is the biggest issue here, one that so many people have issues with, is 1. Is 1 divisible by two different numbers, 1 in itself? No. 1 is divisible by 1, not two different numbers, 1 and itself. So 1 is actually not prime because it's not divisible by two different numbers, 1 and itself. Our first integer, a positive integer value that's prime is actually 2. So some interesting discussion there. All right, so let's go ahead and move on to our lesson for today, which is interpreting parameters of an expression. And for the most part, these are going to be linear expressions, but just in general, expressions, and interpreting them in terms of their context and their their parameters. So in this first one, it says if X is the number of pounds of should be caramels, not varimals, included in the box, and Y is the number of pounds of truffles in a box, then I can write the following equations based on what I know about one of these boxes. So we have X plus Y equals 3. Then we have 8X plus 12Y equals 29. And then we have some questions over here that we want to answer. So how many pounds of candy are in the box? So let's think about what we have here. Let's look at the first equation. X plus Y equals 3. X is the number of pounds of caramels. Y is the number of pounds of truffles. So if we take the total pounds of caramels plus the total pounds of truffles, and it equals 3, well, isn't that the total number of pounds of candy in the box? So 3 is the total number of pounds of candy in the box. So just thinking about what these mean and then what the sum would mean. The sum of X plus Y would mean the total number of pounds in the box. Okay? Then we drop down here. 8 times the number of pounds of caramels plus 12 times the pounds of truffles equals 29. So the only other thing that we might be dealing with here is cost and a total cost. So maybe that's what this equation means. Let's see if we can figure this out. So if we multiply 8 times every pound of caramels, maybe that means that 8 is the cost per pound of caramels of this box, plus 12 times the pounds of truffles. So maybe the truffles are $12 and the caramels are $8. And if we add the total cost of the caramels plus the total cost of the truffles, maybe we get the total cost of the whole entire box. So if we dissect this equation into individual pieces, we have cost of caramels plus cost of truffles equals the total cost of our box. So if we go here, what's the price per pound of caramels? That's going to be 8. And then of course the price per pound of truffles would be 12, which is what, let's see, what does the term 12Y in the second equation represent? That's the total cost of truffles, right? If we had 1 pound of truffles, it would be $12. If we had 2 pounds of truffles, it would be $24, and so on. So 12Y just represents the total cost of truffles in this box. And so that's kind of what we're getting at today is dissecting these equations, expressions, whatever we have, and figuring out what each component in that expression or equation means. And that's our goal for today. So hope that kind of gives you an idea of where to start. Okay, we also want to think about how we can compare expressions and maybe see which one's greater or less or whatever. So this one's a little bit complicated here. You're going to have to really think about these. In the paragraph up here, it says we have P and Q, which are size of 2 different animal populations, where Q is greater than P. So that's a huge piece of information that Q is greater than P. So you could, as you're going through here, you'll pick a value for Q, pick a value for P, and you could test some values out as you go, and see which one's greater here. But what I want you to do is go through A through F and see if you can figure out which one of them is greater, or maybe they're equal. So take a second to do that. Okay, so in A, let's just go through these. In A, P plus Q and 2P. So again, a couple of different ways to do this. if we had 2p, isn't that the same thing as p plus p? So we're comparing p plus p to p plus q. So these p's, offset, right? They're equivalent. And then, so really all we need to do is compare this p and this q. Which one's greater? Well, we know that q is greater than p, so therefore p plus p is going to be less than p plus q. So that means that p plus q, I'm going to circle that one here, is greater than 2p. So I hope that makes sense there. If you pick some values, maybe we'll pick q for animal population. Let's say that is, 12, and p is, we'll say 10. So we're just going to pick some values here. And this is a great strategy for things like, ACT, SAT. If you're comparing values, maybe just pick some numbers and see what happens. Because 12 is indeed greater than 10. Okay, so let's see. P plus Q would be 10 plus 12. And we're comparing it to 2P, which is 20. 2 times 10 is 20. Well, let's see. 10 plus 12 is 22, which is greater than 20. So again, that tells us that P plus Q is greater than 2P. All right, let's go on to the next one. P over P plus Q and P plus Q over 2. So here's how I thought about this one initially. P plus Q. Again, Q is bigger than P. So if we just think of this as P over P plus, we'll just do P for a second. So really we have P divided by 2P would be 1/2, right? But it's not. It's actually P plus Q. So the denominator here is actually going to be bigger than this one, right? This denominator is bigger than this denominator, all right? So that means that P over P plus Q, if the denominator is bigger, that means the overall number is going to be smaller than what we got by doing it this way. So that's actually going to help us out down here on part E, if we compare that. Because again, if we were to put P in here, this denominator would get smaller, therefore it would be equal to 1/2 if it was P. But because we increased it by putting in Q, it's going to be less than 1/2. Well, let's just try some values here. So if P is 10 and Q is 12, that would be 10 divided by 10 plus 12, which would be 10 divided by 22. Okay, and then we're going to compare it to P plus Q over 2. So P plus Q over 2 is, let's see, that'll be 10 plus 12 is 22, over 2 is 11. Okay, so which one's greater? Obviously the right expression, this one here, is going to be greater. And that will always be the case. Because let's go back to our P's and Q's here. If we know that this fraction is less than 1/2, this fraction represents the average of P and Q. Right? If you add the two numbers and divide by 2, you're going to get the average of P and Q. And since we're talking about animal populations, you're going to have an integer value. So if the populations are 1 and 1, this average is still going to be 1. So it's always going to be greater than 1/2. And so this one is going to be greater than there. I know that's a little tricky to figure that one out. Hopefully you're able to kind of go with me through that process. All right, next one. We have Q minus P over 2 and Q minus P over 2. I mean, you could pick some values and compare them. That would be easy enough here. But I want to show you how this could work maybe algebraically. So if we have Q minus P in parentheses divided by 2, we can actually divide both of those quantities by 2. So that's going to be this equal to Q over 2 minus P over 2. So we're comparing Q over 2 minus P over 2 to Q minus P over 2. So again, the minus P's over 2, those are equivalent. So all we really need to do is compare Q divided by 2 to Q. And obviously half of Q is going to be less than Q. So therefore, this one is going to be greater. Okay? D, we'll do that one real quick. 50t and 50t, we don't really know what t is exactly, but those are equivalent expressions. So really all we need to do is compare P and Q. And Q is going to be greater, so therefore this side is going to be the greater one. Okay? And then E, we already talked about this one. P over P plus Q is less than 1/2. So therefore 0.5 is going to be greater on that one. And then let's see, P over Q and Q over P. So, so Q is greater than P. So here, Q is greater than P. So this is going to be a bigger number than this one. So that means that this overall number is going to be bigger than 1. So if we could pick our numbers in, we have 12 over 10. Since the numerator is larger, then this value is going to be larger than 1. Over here, though, the numerator is going to be smaller. So you have 10 over 12, for example. If the numerator is smaller than the denominator, then we have a value less than 1. Therefore, we know that this second fraction is going to be greater. So in fact, all of these, the answer was the second expression except for the first one. So hopefully you're able to follow me through that process. Just, again, thinking about number sense, working through things algebraically, but you could also plug in numbers and kind of check things as you go as well. All right, lastly, let's take this situation, kind of combine some ideas that we've been talking about today, and see what we can do here. So it says a company uses 2 different sized trucks to deliver sand. The first truck can transport X cubic yards, and the second Y cubic yards. The first truck makes S trips to a job site. So I'm going to circle what the first truck does. The first truck takes X cubic yards and makes S trips. And in green, the second truck takes Y cubic yards and makes T trips. What quantities do the following expressions represent in terms of the problem's context? So let's go through each one of these and see what we can come up with here. So S plus T. S plus T. So if the first truck makes S trips, the second truck makes T trips, S plus T would be the total number of trips, right? So S plus T is the total number of trips when you're combining both trucks. X plus Y. X is the number of cubic yards the first truck takes. Y is the number of cubic yards the second truck takes. So that's going to be the total number of cubic yards taken by both trucks per trip. So I'm going to put per one trip each. All right, part C here, XS, so it's the number of trips the first truck makes times the number of cubic yards it takes, plus Y is the number of cubic yards the second truck takes times the number of trips. So basically, if we take, 5 trips and 2 cubic yards each time, that's going to be 10. So it's the total number of cubic yards that the first truck takes, total number of cubic yards that the second truck takes. Add them together, you get the total number of cubic yards that are taken all together, not just per one trip. Okay? So this is the total number of cubic yards combined. D, xs plus yt. So basically this expression here divided by s plus t. And again, s is the trips of the first truck, t is the trips of the second truck. So if we take the total number of cubic yards divided by the total number of trips, we should get the average per trip. So this is going to be the average cubic yards per trip, right? So total number of cubic yards divided by total number of trips. And we should get the average cubic yards per trip. All right? So again, taking a context and then thinking about what various expressions mean in that context. And that's going to really help later on this semester when we get to systems of equations and taking a context and writing some expressions that represent it. So this kind of lays the groundwork for that. But also gets us thinking about linear functions and linear expressions and different things there as well, and what those parameters mean as well. So hopefully that means that we reached our goal for today, which was to interpret expressions, the parameters of expressions, and do all kinds of things with them in terms of relate them back to the context, but also compare their quantities and that kinds of thing. All right. So hopefully you'll join us for our next lesson, lesson 3 in this unit, and so hopefully we'll see you then.